Hi everybody, this video is about graphing quadratic functions. So what we're going to do is start with the simplest quadratic function you can possibly imagine, f of x equals x squared. Now I've already made an xy table for this function because it's really easy to do. It'd be boring to watch me write this out, but negative 3 times negative 3 is 9, negative 2 times negative 2 is 4, and so on. So if you generate a list of xy values, this is the simplest way to graph. If you plot all of these points, I'm going to start in the middle at 0, 0. As we'll see in a minute, that point is special. So there's 0, 0. Then we have 1, 1. We have 2, 4. We have 3, 9. And we have very similar points to the left. So negative 1, 1, negative 2, 4, and negative 3, 9. So if you connect the dots, which I probably won't be able to do very well with this writing tablet, do the best you can though. If you connect the dots, you get this shape, and this shape is called a parabola. P-A-R-A-B-O-L-A. Parabolas are really common in mathematics. They show up all the time. So here's a little bit of vocabulary for parabolas. This basic parabola has its vertex at the point 0, 0. That was the point we started with. This parabola points up. As you'll see in a little bit, we can turn parabolas upside down and make them point down. And something that you also see is that parabolas are symmetric. If you draw a line up and down through the vertex, so this line I'm drawing in red, if we were to fold across this dotted line, then everything would line up. So that line is called the axis of symmetry. And anyway, that's how you graph this really basic parabola. But what we need to do is learn how to graph any parabola, so any quadratic function, not just f of x equals x squared, but f of x equals, I don't know, 3x squared minus 5x plus 7. That's still a quadratic function, and its graph is still a parabola. Now, before we go to the next example, I'm going to go ahead and write something down which will turn out to be useful, a little hint for making graphing parabolas go fast. Because the idea is we don't want to make an xy table every time we encounter a graph. That would just take way too long. So rather than thinking about this xy table, this really basic parabola starting at the vertex, which is 0, 0, think about this in terms of movement. From the point 0, 0, to draw the next set of points, you go over 1, up 1. And then you go over 2, up 4, because 2 times 2 is 4. And then you go over 3, up 9. So starting at the vertex, that's how you can get to these 3 points. Just remember, every time you do this counting, you start at the vertex. So from the vertex, I go over 3, up 9, because 3 squared is 9. Now, I know this seems really silly to even point this out because the same information is here in the xy table, but as you'll see in the next example, it turns out to be pretty useful. I am going to clear the entire screen. I'm going to have to rewrite this over 1, up 1. But I did want you to know where I was going before we headed to the next example. So here is a quadratic function written in vertex form. If you haven't already watched my video on finding the vertex, converting to vertex form, you'll need to do so. If you have a quadratic and it's written in standard form and you want to graph, your first step is going to be to convert to vertex form. Now before I jump in, let me just rewrite what I had a minute ago. From the vertex of that really basic parabola, to get the other points, we went over 1, up 1, over 2, up 4, over 3, up 9. If you had some really big graph, I suppose you could keep going to over 10, up 100, but I've never needed to do so. Anyway, let's graph this parabola. The reason vertex form is called vertex form is looking at vertex form, you can tell where the vertex of the parabola is. I'm going to go ahead and write the answer here. The vertex of this parabola is at 1, 2. Well, let me explain why. So, this number out on the end moves that basic parabola that we did in the last example up and down. So it moves the y-coordinate of the vertex to 2. And then this number inside, grouped in with the x, that moves the parabola left and right, so it moves the x-coordinate to 1. Now, you can obviously see how you could get confused here. We have a plus 2, and the y-coordinate is plus 2. Your eyes are showing you a negative 1, but we changed that to a positive 1. If you want to just remember to change the sign of the number grouped in with x, I suppose you can. However, the way it really works is this movement is based on subtracting. I'm subtracting the number 1. This is a positive 1 that I'm subtracting. If I were to move this 2 to the other side and interpret f of x as y, this would say y minus 2, and it would be the same thing, whatever number you're subtracting. So you can either think about it in terms of subtraction, or, like I said, just remember the number grouped in with the x, you have to change the sign of that one. Okay, so let's get around to the graph. We're going to start at the vertex, which is at 1, 2. So the vertex is here. Now, the last thing that we have to talk about is this number. Okay, we're multiplying a function by negative 2. We're multiplying y values by negative 2. But that also interacts with, well, the graph being moved up and down. So it's actually a pretty complicated interaction. You can spend a whole lot of time in an Algebra 2 class studying nothing but graphing. Long story short, for parabolas, and my shortcut for graphing them quickly, is we want to take this negative 2, the number in front that we're multiplying, and we're going to multiply. We're going to multiply all of these y values. I'm interpreting these up and down numbers as y values. So I'm going to multiply all of these by negative 2. Just the up values, not the over values. So I'm going to multiply those by negative 2. Now, because this number is negative, that changes up to down. If you listen to a lecture in class about this, what you're doing is you're taking the basic parabola and you're reflecting it across the x-axis, you're turning it upside down. But anyway, up becomes down. And 1 times 2 is 2. And here we're going to go 4 times 2, we're going to go down 8. And 9 times 2, I don't think we're actually going to have room on our graph for this. That's fine though. If we did, we'd have to go down 18. So I'm going to start at the vertex. I'm going to go over 1, down 2. I'm going to go ahead and do that on both sides, over 1, down 2. And then we're going to go over 2, down 8. Feel free to use some arithmetic at this point. If I'm sitting at the y value of 2, I go over 2. If I go down 8, well, if I'm at 2 and I go down 8, I would end up at negative 6. And I know parabolas are symmetric, so rather than going all the way back, I'm 2 away from the axis of symmetry, so I can go 2 away from the axis of symmetry. But anyway, this is a really fast trick for graphing parabolas quickly. I'll do my best to connect the dots here. When you're graphing parabolas, try not to make a corner or some jagged edge at the vertex. In reality, this is a really nice, smooth curve. It actually flattens out momentarily. You'll study that in calculus though. But anyway, if you have vertex form, graph the vertex, play this little trick for figuring out how far you go up and down, and you're done. So the real work is in the prior video on converting from standard form to vertex form. Okay, I think I have one more example. So here we go. It doesn't matter that this is a fraction. It'll work exactly the same way. So let's identify where the vertex is. So the vertex. So this number grouped in with the x, that gives us the x-coordinate. Remember, you have to change the sign of this one, so it's negative 2. And then the number at the end, that gives you the y-coordinate. So the vertex is at negative 2, positive 1. And you can go ahead and plot that if you like. Now, I do really like this trick of thinking about movement from the vertex. So once again, excuse the delay, I'm going to write over 1, up 1, over 2, up 4, and then over 3, up 9. That's what that really basic parabola does that we did as the very first example. So we're going to take the number 1/2, the number sitting in front, and we're going to multiply all of these values by 1/2. Since this is a positive number, we're still going to go up. We haven't turned the parabola upside down. 4 times 1/2 is 2, and 9 times 1/2, I'm not going to use a fraction, I'll just use a decimal. 9 times 1/2 is 4.5. And we may not have room for that, and we don't. That's fine though. Okay, so we're going to go over 1, up 1/2. So my graph does have fraction lines on it, so I can do this nicely. Over 1, up 1/2, and then over 2, up 2. So over 2, up 2. Over 2, up 2. So there you go. That's how you graph parabolas. Just put the vertex in the correct spot and then count by thinking about the basic y equals x squared parabola. Anyway, that's how you graph parabolas. As long as they're in vertex form, you're good to go. If they're not in vertex form, well, that's probably going to be your job to do the conversion. Anyway, hope this video helped.